Hello and welcome to the 2D AI anomaly detection tool video in the Signova series. In this tutorial I will show you how you can easily distinguish good from bad parts by simply teaching in only defect-free images. This makes a machine vision a lot simpler and can help you to detect more complex defects, especially those where errors cannot precisely be defined in advance. As always, I used the same chocolate samples, but this time check for deviations and errors. To follow along, get yourself an Inspector 830 with the Signova sensor app and download and print the chocolate sample wrappers. Your local SIG sales representative is happy to support you. My Inspector 830 is mounted parallel to the table with a distance of around 35 centimeters. It's connected to my PC using the USB-C service interface, but Ethernet works fine as well. To access the user interface, open a web browser like Google Chrome and enter the default IP address of the USB connection 169.254.0.1. My device is equipped with an Intelligent Inspection Toolkit license, so I can use all tools, including the AI tools, unrestricted. The currently licensed toolkit is stated in the top of the user interface. If you have installed a Quality Inspection Toolkit license, the AI tools can still be tested for a trial period. Once satisfied with the results, just order the Intelligent Inspection Upgrade license for unlimited use. Place the chocolate at the expected position in the field of view. Switch to Configure in the top right corner and click Update Reference Image below the live image. You will automatically switch to the Reference tab. The AI anomaly detection tool can handle minor position variations itself. In case the parts move around more, consider using the object locator to improve the localization. In my chocolate bar application, I assume that the placement is quite repeatable, so I will go without the object locator for now. To apply the tool, click on Add Tool in the Analysis section and select AI Anomaly Detection. Move the AI Anomaly Detection region onto the chocolate and adjust the size to include the chocolate bar and leave some margin for position variation. Everything in the region is inspected, including the background. Now I collect images from both good samples, so without defects, and bad samples with defects. Only the good images are used to actually train the tool. The bad labeled images are used for automatic threshold adjustment. The more your good parts vary, the more images you should collect to capture possible variations. As the variation of my chocolate bars is quite small, 10 to 15 good images should be sufficient. Switch to Live and select Free Running. Move the chocolate bar around within the tool region and add good images to your collection. To do so, find the Good Images section on the right and select Add Active Image to add the currently visible image to this dataset. Make sure to include all relevant positions and variations. Now scroll down to the Bad Images section. Add images of multiple defective or wrong parts in different positions to the bad image dataset. If you're using your inspector with a trigger, the auto collection feature will speed up the image collection a lot. Let's train the AI anomaly detection tool with the collected images. Click the Train button in the Training and Evaluation section. Add number of training images. You can either go with the preset value or fine-tune it to match your application's need. Up to 100 images can be trained directly on the device. The rest of the images will be reserved for evaluation. The Tool Performance slider allows you to adjust a trade-off between higher speed and higher sensitivity. In a faster setting, the tool will be able to recognize larger defects, while in a more precise setting, smaller defects will be detected. As speed and precision counteract to each other, you might need some iterations to find the optimum for your specific application. In my chocolate bar application, I choose a middle position. The strict matching option should be used if the position or presence of a detail is of importance, often used in combination with the object locator tool. I deactivate this option as the position of my chocolate bars vary a bit. Select Confirm to start the AI training process. Depending on the number of images and training settings, it might take some time to complete the training, but often it's done in just a few seconds. As soon as the training is finished, the window will close automatically and the message "Successful trained" will be shown in the bottom right corner. In the live image, the color of the AI anomaly detection tool frame indicates the overall tool result, with green representing a pass and red a fail. In addition, a heat map is shown on the image, visualizing areas where the active image differs from the good training images. The colors in the heat map go from blue, showing areas with minor variations, to green, to red, indicating major variations. In my case, the tool just detected minor differences, which makes it hard to see those areas. So I scroll down and adapt the visualization range. In the results section, you will find the anomaly score. This number indicates how much the image differs from the good training images. The slider position defines the anomaly score threshold. If the active image has an anomaly score above the threshold, it is predicted as bad. If the score is below the threshold, it is predicted as good. Now let's verify the training results using both the good images that we reserved for the evaluation and the bad images. Click on Evaluation to start the process. In the Evaluate Images window, you can see all used images and their results. The thumbs up and down icons display the good or bad image datasets, the anomaly score, and the color indicating if the tool prediction matches the good or bad labels. Select Auto Threshold in the Settings section and let the tool find the best threshold automatically. Click Confirm to save the threshold. Let's test if the AI can detect all anomalies while placing and moving different chocolate bars around. If the object is not present in the image, it will be considered as an anomaly, since uncovered parts of the background differ from the good training images. And as soon as I place the correct chocolate bar, the overall result will be a pass. Wow, that was easy yet impressive, wasn't it? This simple workflow enables a fast changeover to new products or updated product designs with just a few clicks. The 2D AI anomaly detection tool can be used in a wide range of industries and applications. For example, detecting contaminations in food and beverage containers, inspection of soldered parts on electronic boards, or monitoring of injection molds. In the upcoming tutorials, I will show you how you can easily classify objects using the AI classification tools in Signova. If you can't wait to get started, get in touch with your local SIG sales representative now to find out more about the incredible world of Signova.